I'm Neil Grodnick, and this is my AERO4842 case study presentation. So, for my case study, I have made a Surge Coil magnetometer. This is my current setup, but my previous one had a ferromagnetic rod going throughout the coil. But since that one was harder to visualize the magnetic field strengths, this is the setup I have went with. So the basic premise of how I'm calculating the magnetic field strength is with this equation here. So as the surrounding magnetic field around the magnetometer changes, or how the interaction through the poles on Earth, for example, how those field strengths are affecting the magnetic field around the magnetometer, a different induced voltage E should occur, resulting in a change in voltage measured through the Arduino. So as we can see here, with no voltage going through the magnetometer, it is still, the compass in the middle for visualization is still facing north, and plugging back in the connection still north because the magnetic field created by the Surge Coil is facing north through the right hand rule. And if we turn the magnetometer or the Surge Coil to the right, you can see the compass also changes its direction. Here it's not turned at a 45-degree angle, which means that the magnetometer is creating a lower magnetic field strength than the one induced on the system by the poles of the planet. Using this angle and the turning, the induced voltage should, or when the magnetometer is facing right, the induced voltage should decrease. However, that was unfortunately not the case for my experiments. So as we can see here, this is the ADC voltage value, or the ADC voltage that is being measured from the Arduino. So turning the magnetometer to the right should have a change in the ADC value, but unfortunately that does not occur. I tried turning this into a voltage divider, but the results did not change from that also, unfortunately. So this is what I ended up with for my final magnetometer. The way that we do measure the magnetic field strength is by taking the angle of the compass and taking the tangent of that and multiplying it by the magnetic field strength created by the magnetometer, and with that you get the local magnetic field strength around where the magnetometer is located, which can be used to find magnetic poles or magnetic anomalies around the magnetometer. That is my presentation. Thank you.